Ocean waves have a major influence on the marine environment and ultimately the planet's climate. But ocean waves can't exist by themselves. There must be some sort of displacement that causes the water particles to move relative to one another. In the case of ocean waves, this is usually due to wind. Also, water molecules display both transverse and longitudinal components. Note that water particles do not travel, but only their collective energy does. Like other waves, an ocean wave's energy is proportional to the square of its height. So a 3-meter high wave has 9 times more energy than a 1-meter high wave. When fine weather waves about 1 meter high pound on the beach, they dissipate an average of 10 kilowatts per meter of beach, or about the power of a small car at full throttle every 5 meters. But how does wind cause waves? Well, wind blows over the water, changing its surface into ripples and waves. As waves grow in height, the wind pushes them along faster and higher. Waves can become unexpectedly strong and destructive. The biggest waves on the planet are found where strong winds consistently blow in a constant direction. Such a place is found south in the Indian Ocean at latitudes of -40 and -60 degrees, as shown by the yellow and red colors on this satellite map. Waves here average 7 meters, with the occasional waves twice that height. As waves enter shallow water, they slow down, grow taller, and change shape. At a depth of half its wavelength, waves start to rise and their crests become shorter while their troughs lengthen. Although their period stays the same, the waves slow down and their overall wavelength shortens. The bumps gradually steepen and finally break in the surf when depth becomes less than 1.3 times their height. Note that waves change shape in depths depending on their wavelength, but break in shallows relating to their height. This photo shows waves entering shallow water at a break in New Zealand. Notice how the wave crests rise from an almost invisible swell in the far distance. As they enter the shallow water, they also change shape. Although their period remained the same, their distance between crests and their speed diminish. Surf breaks are classified into 3 types: spilling breaks, plunging breaks, and surging breaks. Spilling breaks break gradually over considerable distances. Plunging breaks tend to curl over and break with a single crash. Surging breaks peak up but surge onto the beach without spilling or plunging. Even though they don't break, surging waves are still classified as breakers. When waves break, their energy is absorbed and converted into heat. The gentler the slope of the beach, the more energy is converted. Steep slopes such as rocky shores do not break waves as much but reflect them back to sea, which shelters marine life. Why do waves travel in sets? Part of the irregularity of waves can be explained by the interference between 2 or more wave trains of different periods, moving in the same direction. This explains why waves often occur in groups or sets. The diagram shows how 2 wave trains, the dots in the thin line, interfere, producing a wave group of larger amplitude, which is the thick line. Anyone having observing waves arriving at a beach will have noticed that they are loosely grouped in periods of high waves alternated by periods of low waves. Waves aren't always fun and games though, they can be devastating. Tsunamis are caused by undersea earthquakes, seabed slides, or large volcanic eruptions, and therefore are equally impossible to predict. The way they make themselves felt varies considerably depending on the distance traveled, their magnitude, and the form of the coast. Tsunamis are large waves traveling at high speed. If you ever see the ocean pulling away from the shoreline, there's a good chance a tsunami is coming. Mega tsunamis can be caused when asteroids hit the Earth or when volcanoes explode. Now that we all know about ocean waves, we can have a better enjoyment of them and at the same time appreciate and respect the power the ocean is capable of producing.
Okay.